Hello viewers, in today's class we are going to solve some important problems on definite integrals, right? So let us take the first problem. So here we have to evaluate this definite integral from 0 to pi x tan x divided by sec x plus tan x. So let us call this integral as I, and suppose this is equation 1. Now here we'll apply the property that is 0 to a f of x dx is equal to 0 to a f of a minus x dx, right? So applying this property to this integral, it becomes I is equal to 0 to pi, and here for x we have pi minus x, and then we have 10 pi minus x divided by sec pi minus x plus 10 pi minus x. Now simplifying it, we have 0 to pi. Here we have pi minus x, and tan pi minus x is minus 10x, and then we have minus sec x and minus 10x, right? So sec pi minus x is minus sec x, and tan pi minus x is minus 10x. Now I is equal to here we can write it as 0 to pi, and this is pi minus x tan x divided by sec x plus 10x, right? Because this negative sign and this negative sign from the denominator both get cancelled, and now we have 0 to pi. So separating it into two integrals from here, so we have pi tan x divided by this is sec x plus tan x dx, and then we have 0 to pi, this is sec x tan x and sec x plus 10x, right? Now this integral is I, so this equation can be written as I is equal to pi, taking pi out of this integral, so we have 0 to pi, and then we have 10x, and here we have sec x plus 10x and dx, and this is this integral becomes I. So taking this I to this side, we have 2I, and this is pi 0 to pi, and 10x can be written as sin x divided by cos x divided by 1 over cos x, and this is sin x divided by cos x, right? So viewers, this becomes pi by 2, this is 0 to pi, then we have sin x, and this is 1 plus sin x, right? Now I can be written as pi by 2, here we have 0 to pi, and then we can write it as sin x over 1 plus sin x, and multiplying the numerator and denominator by 1 minus sin x. Okay, now I becomes pi by 2, here we have 0 to pi, and this is sin x times 1 minus sin x, and this is 1 minus sin square x, right? because 1 plus sine x multiplied 1 minus sine x is 1 square minus sine square x. Now I can be written as pi by 2, this is 0 to pi, this is sine x minus sine square x, and 1 minus sine square x becomes cos square x, right? Now viewers, separating this integral into two integrals, we have I is equal to pi by 2, and here we have 0 to pi, and this is sine x over cos square x, and minus this is sine square x divided by cos square x, right? Okay, now we have pi by 2, and this is 0 to pi, and sine x over cosine square x is tan x sec x, right? And tan square x, sine square x divided by cos square x is tan square x. Now this is pi by 2, this is 0 to pi, and this is tan x sec x, and this tan square x can be written as 1 plus tan square x is sec square x, so tan square x is sec square x minus 1. So substituting the value of tan square x here, we have minus sec square x plus 1, right? Okay, now see, here we have 3 terms, and the integral of tan x sec x is secant x, the integral of sec square x is tan x, and the integral of 1 is x, right? And here we have the limits. Now substituting the value of pi here, we have sec pi minus tan pi plus pi, and then we have 0 for x, so we have here sec 0 minus tan 0 and plus 0, right? Now substituting the values of these terms, here we have sec pi is minus 1, and tan pi is 0, and here we have pi, right? And for sec 0 we have 1, and here for tan 0 we have 0, and here we have 0, right? Okay, so we have pi by 2, and this is minus 1 plus pi, and here we have minus 1, so this is pi by 2, pi minus 2, right? And if we take 2 multiplying this term by half, we have pi by 2 minus 1. So viewers, this is the required value of this definite integral. Now let us take this problem. Here we have to evaluate this definite integral from 0 to a sine inverse square root of x divided by a plus x. Viewers, here we will apply first the method of substitution. So let us substitute x equal to a tan square theta, right? So this integral, this expression becomes that is square root of x over a plus x. It becomes a tan square theta divided by a plus a tan square theta. Now this is a tan square theta divided by taking a common, so this is 1 plus tan square theta, so a and a get cancelled, so we have tan square theta divided by sec square theta, and this is tan theta over sec theta. This square is cancelled by the square root, and we have tan theta over sec theta, which can be written as sine theta over cos theta divided by 1 over cos theta, and this cos theta and cos theta get cancelled, so we have sine theta, right? Okay, now this is x equal to a tan square theta, so we have dx is equal to 2a tan theta and sec square theta d theta, right? And now if we change the limits, so when x is equal to 0, we have here a tan square theta is equal to 0, so tan theta is 0, so theta is equal to 0. Similarly, when x is a, we have a tan square theta is equal to a, and a get cancelled, so we have tan square theta is equal to 1, so theta is equal to tan theta is equal to 1, so theta is pi by 4. Now this integral becomes I is equal to from 0 to pi by 4, and here we have sine inverse, and for this expression we have sine theta here, right? And for dx we have 2a tan theta and sec square theta d theta, right? Now by the definition of sine inverse, this sine inverse and this sine get cancelled, so we have here 2a, and this is 0 to pi by 4, and here we have theta, then we have tan theta sec square theta d theta. Now viewers, here again we'll make a substitution and let y is equal to tan theta, right? So dy becomes sec square theta d theta, and from here we have theta is equal to tan inverse y, so and the limits can be changed to, again when theta is 0, y becomes 0, and when theta is pi by 4, y becomes 1, right? So this integral I now becomes, here we have 2a, then we have 0 to 1. For theta we have tan inverse y, and for tan theta we have y, and for sec square theta d theta we have dy, right? So viewers, so we have the integral I as 2a 0 to 1, and we have y tan inverse y dy. Now this becomes a product of two functions, and here we will apply integration by parts. Now viewers, applying the method of parts to evaluate this integral, that is y multiplied tan inverse y dy. So here this is u and this is v. So this is the first function, the inverse function, and this is the algebraic function. So the formula for parts is given by this expression. So substituting the value of u and v, we have this expression. Now the integral of y is y square by 2, and here we have tan inverse y minus integral. Here we have the derivative of tan inverse y is 1 over 1 plus y square, and here we have y square by 2 dy, right? So now this is y square by 2 tan inverse y minus, and here we have half, and y square over 1 plus y square dy. Now this is y square by 2 tan inverse y, and here we have to evaluate this integral. So what we will do, we will write it as 1 plus y square minus 1 divided by 1 plus y square, right? So we have expressed y square as 1 plus y square minus 1. Now this is y square by 2 and tan inverse y minus half, and this is 1 minus 1 over 1 plus y square dy. Now this is y square by 2 tan inverse y minus half, and this is y, integral of 1 is y, and this is tan inverse y, right? So this is the value of indefinite integral. Now we have to substitute the limits. Now viewers, this integral I now becomes 2a times y square by 2 tan inverse y and minus half y, and minus and minus plus, and here we have half tan inverse y, and the limits are from 0 to 1. So now this can be written as 2a, and here we have for y is equal to 1, here we have 1 square by 2, this is tan inverse 1, this is minus half times 1 plus half tan inverse 1, right? And then we have minus, and we'll substitute y is equal to 0 here, so this term becomes 0, this becomes 0, and here we have half tan inverse 0, right? Okay, now this is 2a, and here this is half, and tan inverse 1 is pi by 4, then we have minus half, and this is half times pi by 4, and all these terms become 0 because tan inverse 0 is also 0. Now this is 2a, and this is pi by 8 minus half plus pi by 8, and this is 2a, and this is 2 pi by 8 minus half, and this becomes 2a pi by 4 minus half, and multiplying these two terms by 8, we have a here, then we have pi by 2 minus 1. So this is the required value of this definite integral. So the value of this integral is a times we have pi by 2 minus 1. Now viewers, let us take one more problem. Here we have to integrate this integral square root of a minus x divided by a plus x from minus a to a. Here again we'll make use of substitution method and let x is equal to a cos 2 theta, right? So we'll make this substitution here. So this expression, that is square root of a minus x divided by a plus x, it becomes a minus for x we will substitute a cos 2 theta. So we have here a minus a cos 2 theta divided by a plus a cos 2 theta. Now this becomes taking a common, so we have 1 minus cos 2 theta, and here we have a times 1 plus cos 2 theta. Now a and a get cancelled, so we have 1 minus cos 2 theta is 2 sine square theta, and 1 plus cos 2 theta is 2 cos square theta. 2 and 2 get cancelled, so we have sine theta over cos theta, that is equal to tan theta, right? Okay, now x is a cos 2 theta, so this is dx equal to minus 2a sine 2 theta d theta, and here we can change the limits also. So we have when x is minus a cos 2 theta is equal to minus a, so cos 2 theta is equal to minus 1, so 2 theta is equal to pi, so theta is pi by 2. And similarly when x is a here, so we have a cos 2 theta is equal to a, and cos 2 theta becomes equal to 1, so 2 theta is equal to here a and a get cancelled, so cos 2 theta is equal to 1, so 2 theta is equal to 0, so theta is equal to 0. So therefore this integral now becomes I is equal to pi by 2 to 0, and here we have pi by 2 and here we have 0, so this is from pi by 2 to 0, and for this expression we have tan theta here, and for dx we have minus 2a, this is sine 2 theta and d theta, right? Okay, now this is minus 2a, this is pi by 2 to 0, and here we have tan theta. For tan theta we have sine theta over cos theta, and for sine 2 theta we have 2 sine theta cos theta, and here we have d theta. Now cos theta get cancelled, so we have I is equal to minus 2a, and here we have pi by 2 to 0, and this is 2 sine square theta, right? Okay, now reversing the limits, and so this negative sign will disappear from here, so we have 2a, and it is from 0 to pi by 2, and for 2 sine square theta we can write 1 minus cos 2 theta, right? And now this is 2a, the integral of 1 is theta, and the integral of sine 2 theta is cos 2 theta is sine 2 theta divided by 2, and the limits are from 0 to pi by 2, right? Okay. Now substituting the limits here, we have 2a, then we have pi by 2 minus sine 2 times pi by 2 divided by 2, and here we have minus, and substituting here the value of theta is equal to 0. Here theta is pi by 2, so this is 0 minus sine 2 times 0 divided by 2. Now I becomes 2a, this is pi by 2 minus 2 and 2 get cancelled, so sine pi is 0 by 2, and here we have 0 minus sine 0 is 0, right? And I becomes 2a, and this is 0, this is 0, this is 0, so we have the term pi by 2. Now 2 and 2 get cancelled, so we have I is equal to a multiplied pi, right? So viewers, the value of this definite integral is a pi.